All right, going to recover a couple of the questions on the ready, and then we're going to talk about the set today. Simple concept. In the ready, question number 1 is 13. Question number 2 should be 1. Question number 3 is 3.8, or you could leave your answer as the square root of 15. And number 4, what was number 4? I put my paper away. Sorry, I'm trying to think off the top of my head. I think number 4, number 4 should have been, I'm sorry, don't even want to guess here. It's been a long day. Number 4 is 3, all right? So if you have any questions on 1 through 4, let me know. Number 5 right here, I didn't cover anything yesterday in the video because I wanted you to do something today. And I told you how we solve these. We solve these by cross multiplying. So if I'm going to cross multiply here and here, do something. 5c is equal to the square root of 29 times 15. That's something. A lot of people didn't want to do anything because they're intimidated by the square root of 29. Well, think about it. If I do this and I get to here, assume that I do something with this. If I do something with that, what's the next step? The next step is to divide by 5. And c gets by itself. Well, over here, why do I want to multiply this and divide by 5 when I can make things easier on myself and reduce 5 and 15 and get 3? And I get the square root of 29 times 3. Now this doesn't look normal to us. So instead of saying the square root of 29 times 3, we flip-flop these and we get 3 times the square root of 29. Now the biggest thing I want to stress to you is, what is this? What is this as a number? We'll go back to here. What is this as a number? Well, if the square root of 25 is equal to 5, then the square root of 29 is 5.2, 5.3, 5.4, somewhere around in there. The correct answer is 5.3. So if this is 5.3, that's a reasonable answer for this because it's the hypotenuse. Then this is like 3 times 5.3, which is approximately 15.9. Reasonable, all right? It's just a matter of thinking a little bit, okay? So now we move on to the set. And in the set, the theory behind this is it's talking about parallel lines and transversals and that their relationship is proportional. So here's question number 7. Instead of spending a long time talking about this, I'm just going to use this example. And the example that I used was question 7, which actually I think is labeled horribly. I asked the students all day, which lines can you tell me are parallel? And we sat here and we got a lot of like, I don't know. And then a couple of people said, well, the lines that don't cross, which are these right here. A lot of students wanted to say line A, line B, line C, line D. No. A and B represent the length between, it's the length of the segment between these lines. That's what A and B represent. Same with C and D. So if I look at this, how can I determine what lines are parallel? Well, gee, it's the lines that don't cross. That's one way. Okay, that was a good example. Or the other thing I brought up was, what about the 3 negative sloping lines? If you look at this as a coordinate grid. Here's my x-axis, here's my y-axis. Well, okay, fine. These lines are parallel. If I look at them as similar figures, blue triangle, red triangle, green triangle, and compare them like we did over here, we know that similar figures are proportional. That's essentially what we have here. So if we look at this, we can say that, hey, and the theory states that if 2 or more lines are parallel that are cut by a transversal, their sides are divided proportionally. So I can say A over B, that's how I made that proportion. A over B is to D over C. Or A over D is equal to B over C. Either way, I do this. I'm consistent in what I'm doing. Now, the directions say you need to create a third proportion, okay, or a third ratio. So you need to do that. I'm not going to talk about that now. The other thing I want to talk about, though, is question 8, and I'm going to go 9, and I'm going to cover 12 and be done. Number 8 is tricky because it doesn't give me an actual numerical number or a letter for the length of this segment, which, by the way, something I missed in 7, and one of the things that these two examples don't do is a lot of times in geometry it will label the lines with lowercase letters. Okay, so Q, R, and S, and then it'll do lowercase t, and then maybe a lowercase v, something like that. So now when it says line R, you know it's this line. Line S, you know it's that line. That's another thing in notation. That's what made 7 so hard, is we couldn't notate it with lines, and it didn't give letters here. And then this one is tough because it doesn't give me the letters here as well. So how do I notate this? Well, the only way I can notate this is if I say segment DE or segment ED. One of those two. It's still talking about this same segment. So if I go with that philosophy, I could create a proportion stating this segment, which is DE, over FG, segment FG, is equivalent to DC over AF. And you also have one more for this diagram, right? So you need to create that. Now, maybe letters aren't your thing. Maybe numbers are. I get it. Well, here we need to create the proportion. We have 3 parallel lines cut by 2 transversals, right? Create the proportion. I could do this a couple of ways, but one is 2 over n, because again, this is what we're finding, right? 5 over 6.5. Cross multiply and solve. All right? And if you pause a second, if you're busy, look at questions number 11 and 12. Those are the only 2 we have to do at the bottom there. If you look at those, you can look at the diagrams and see which lines are parallel. In 11, which lines are parallel? Pause a second and look at that and see which lines are parallel. You should say CB or BC and DE or ED. Either one of those are parallel. And then the last one, observe which lines are parallel. Gee, if I look at this diagram, BA, FG, and DE are parallel. Right? And it wants you to notate that. It gives you an example. And it also talks about writing a similarity statement. Not a congruent statement, but a similarity statement. If you look at the top of the board here, and I had to move the camera a little bit, I give you an idea how to write a similarity statement. This is a congruence statement because it has a congruent symbol. This is a similarity statement because it has a similarity. Remember, these triangles were not the same. They weren't congruent. They were similar. So we use the symbol for similarity. So triangle ABC is congruent. That's a congruent statement. Triangle ABC is similar. That's a similarity statement. So make sure you get those written down. That was it for today.